lesson 38, we have several different topics. First, we're going to review a little bit of probability, stuff that you've seen before with how many different ways can you arrange things. And then we're going to do something called designated roots and overall average rates. So first, a little bit of vocabulary. Permutations are how many different ways can you arrange things in order. It's not how many ways can I pick a committee of 3 out of this class, because it doesn't matter who I pick first. But if I start saying let's pick officers for this class, it makes a difference if the first name is president, the second one is vice president, and the third is secretary. It makes a difference what order I call names out in. So the second one would be a permutation. First one's combinations, which we'll get to later on in the term. And you probably remember, if you have several different things that you're choosing, you're looking for how many ways can you pick the first one, how many ways can you pick the second, how many choices do you have for the third, and then what you do with those is you multiply them together to get how many arrangements you can possibly make for those. Hands up, how many remember doing these in the past? It's not something new. You're forced to review, but it should go pretty quickly for us. So let's do that by going through a few examples real fast here. So if I have the numbers 3, 5, 7, and 8, so maybe I went to the hardware store and I got house numbers to put on a house, but then I don't really know what order they're supposed to go and how many different addresses could I come up with by switching those digits around. I know it has to be a 4-digit address. How many choices do I have for the first one? 4. Now I picked one and I've used it. How many choices are left for the next one? And what do I do with these numbers? So 4 times 3 times 2 is going to give me 24. Reread the problem for a word to label it with. How many different ways? So label it as ways. Easy enough, right? Okay, slight change. Repetition is permitted here. So now I'm just typing, but I've only got 4 keys that work on the keyboard. But I can type E over and over and over if I want to. So we want 4 letter signs, so we're not going to use all 5 of them. How many choices, everybody, for the first one? Really? What letters could I choose for the first one? An E or a Q? How many is that? So 5 choices. I heard some 4s for the first one. So 5 choices for the first one. Okay, I still got those same 5 keys on the keyboard. They all still work. How many choices for the next? And what do I do with them? 5 times 5 is 25. 25 times 25 is 625. Reread what I'm finding. How many signs? So we label it signs. Okay, next one. This is not your math test, but in one of your classes, you are having a multiple choice test with 8 questions, and you decide you're not going to bother to study at all. You are just going to randomly bubble in the Scantron. How many different ways are there that you might fill out that Scantron form? So we have 8 questions that you're going to bubble in. How many choices are there for the first one? And whatever you answered on that one, does that change the number of choices on the next one? So how many choices there? What do I have to do with all these 4s? So that's going to be 4 to the 8th, and my calculator told me that was 65,536. How many sets of answers we could bubble in on that? So moral of the story, 65,536 different ways that you could fill it out. How many of those are 100%? 1 chance out of more than 65,000 to get 100%. And you can only miss 1 and get an A, still get an A. So you'd have 8 other choices for which one you missed. So that gives you a total of 9 out of more than 65,000 chances to get an A. So moral of the story is study for your test. All right, moving on. This is a little bit of review to set us up for what we need to do with what will be called designated roots problems. So I want us to solve this by factoring. So what we would do here starts with 1x squared, so we have 2 parentheses that both start with x. I need something that multiplies to be negative 28 and adds to be positive 3. Can anybody come up with those numbers real quickly for us? Dylan?
Positive 7 and negative 4.
So a plus 7 and a minus 4. So that means our roots would be what? Negative 7 and positive 4. These would be, the word I just used was roots, solutions, zeros. What the answers that we would get for that would be. What the book is going to start doing is the book's going to do this in reverse. The book is going to start here with designating the roots. The roots need to be negative 7 and 4. And then we need to do the steps in reverse order. So that meant if we had a minus 7, the factor had to be a plus 7. We had to take x minus this root, or the opposite sign in there, and each parenthesis started with a 1x. So we would say the x minus the minus 7, and then the x minus the 4. And then for it to have those as roots, what does it have to be equal to? So you'd have to have that in there. The book is going to say that they want you to get the polynomial or the quadratic with lead coefficient 1. So it has to look like that. We've gotten as far as parentheses times parentheses, so we'd have to FOIL it. And we do that, and we'd have x squared minus 4x plus 7x would give us the plus 3x, and the minus 28. And don't forget the equals 0. And that would be the answer that they're looking for when they start by designating the roots for you to come up with a quadratic. The difference is they're not going to give you nice integers most of the time. They're going to give you problems that look more like this, but that's the process we're going to use. We're going to write down 2 parentheses that each start with x, so that x times x will give us 1 x squared at the beginning of that equation. So, from what we did before, we had to take the opposite sign in there. So x minus the minus 3/5 becomes a plus 3/5. And then we have x minus the 1/2. What do I need on the other before I go on? It's got to be equal to 0, or it doesn't have any solutions. Then what do I have to do? FOIL it. It's just going to be messy. So I'm going to have x squared minus a half x plus 3/5 x minus 3/10, and keep the equal 0. These are like terms, so we have to combine them. So this needs times 5 over 5 times 2 over 2. So I've got minus 5/10 and plus 6/10, so plus 1/10 x on that middle term. And this would be my answer because it starts with 1x squared. And it asks for that lead coefficient of 1 in front of the x squared. Even though it would be equivalent, we're not going to clear the fractions and multiply everything by 10. Because that does not start with 1x squared. So does that make sense on designated roots? Okay, final topic for today is something called overall average rate. And it is not that hard, but students have a lot of trouble with it every single year. Overall average rate means you are thinking about the entire trip. And how far did you go total? How long did the total trip take you? What was your rate for average out over the whole trip? Now, those of you that have your driver's license, you can probably relate to this. I never drive at the same rate any entire time that I'm behind the wheel of the car. I come up to a stop sign or a stoplight and I have to slow down and stop. And then I get to speed back up again, but for a little bit there I was going at 0 miles an hour. Or I'm on the highway and I get behind a truck that's going real slowly, or I get in a construction zone and I have to slow down. Or it's just rush hour, and sometimes it's stop and go traffic. I'm not going at a steady speed. Sometimes on a long trip, I stop and take a break, try to get gas, try to get something to eat. And I'm going at 0 miles an hour there. So this is saying if we could have no other traffic there and just go instantaneously from 0 to our average speed, we didn't have to accelerate and we could hold it at that for the whole trip, what would that rate have been? It is not the average of the rates. It is not something like take the different speeds, for different parts of the trip and just take their average. Because maybe I'm going at 80 miles an hour for 5 minutes. But I'm going at 60 miles an hour for 3 hours. That different amount of time, different distance at that different rate carries more weight when we're doing the overall average. So what you want to think about with this is if you were doing a trip, the total distance, the total time, those are pretty easy. And if we could come up with that one steady rate and really hold it at that for every second of the entire trip, what would that rate be? So to get that overall rate, let's isolate that R, and it needs to be the total distance divided by the total time. And that is the formula you need to use. Where students get in trouble is they try to do this shortcut of just averaging the rates. Does not work. And these can get a little bit messy because they don't always tell us things in the nicest form. But we'll have examples that look kind of like this. So we want to work with the overall average rate. And we know that that needs to be our total distance divided by our total time. So they tell us that this trip is in different sections, that for the first leg, it is 100 miles long and 50 miles an hour. They tell us that we have a second leg that is 180 miles long at 60 miles an hour. And they tell us we have a third leg that is 120 miles, and we don't know the rate for that leg. And they tell us that we want the overall average rate to be 60. So we want this overall average rate out here to be 60. Total distance, that part is going to be pretty easy. That's going to be the 100 plus the 180 plus the 120, which is how much? That's going to be 400. Okay, time, they don't tell us, but they tell us the rate for at least that first leg. So if I think about the first leg, rate 1 times time 1 has to be distance 1. So rate 1 was 50, times time 1 has to be 100. So time 1 needed to be that distance divided by that rate, which is how much? Then I could do the same thing with the second leg. So the time on that one would have to be that distance divided by that rate, which was 180 divided by 60, which is how much? Okay, now the hard one. For the third leg, except all that I know is the 120. I don't know that rate. So I could put 120 over R3 right here, or I could just leave it as T3 for right now. And your choice of which way you want to do that. So I have 60 equals 400 over 5 plus T3. So I'm going to do a cross product. I'm going to take the 60 times the 5 plus T3 so that I have 300 plus 60 T3 equals 400. There's cross product there. And that means 60 T3 is 100. So T3 is 100 over 60, or 10 over 6, or 5 over 3. So now I'm going to go back to this R3T3 equals D3 to figure out what R3 has to be. So if I take that, R3 is what I'm trying to find. T3 is 5/3, and distance 3 was 120 miles. So if I want just R3, I'm going to multiply both sides by 3 over 5. And 360 divided by 5, I believe, is 72 miles per hour. And that would be our answer. And you've got to do it this way. There isn't a shortcut on these overall average ones. Anybody with questions there? And we will stop.